The expansion valve is a critical component in your AC system. It controls the flow of refrigerant, changing it from a high-pressure liquid to a low-pressure vapor, which is essential for cooling. When this valve fails, several key symptoms arise, directly impacting your AC's performance. We'll cover the main symptoms in this video. One of the most noticeable symptoms of a bad expansion valve is that your AC blows warm air instead of cold. This happens because the valve isn't metering the refrigerant correctly. It might be stuck open, flooding the evaporator, or stuck closed, starving it of refrigerant. Either way, the cooling process is disrupted. When the valve is stuck open, too much refrigerant floods into the evaporator coil, overwhelming the system and preventing efficient heat absorption from the air. Conversely, if the valve is stuck closed, too little refrigerant reaches the evaporator, starving it and significantly reducing the system's cooling capacity. Another common symptom of a faulty expansion valve is frost buildup on the evaporator coils. This happens when the valve overexpands the refrigerant, causing the evaporator temperature to drop below freezing. Moisture in the air freezes on the coils, creating visible frost patterns that restrict airflow. The frost forms delicate, spiky patterns along the edges of the metal fins, further reducing cooling efficiency. In the evaporator, the coils are tightly packed in an A-frame structure with connections for refrigerant lines. When the valve is faulty, the evaporator temperature drops below 0 degrees Celsius or 32 degrees Fahrenheit, causing moisture to freeze on the coils. High humidity worsens this effect as more moisture is available to freeze, blocking airflow and reducing overall cooling efficiency. Pressure issues are a key indicator of expansion valve problems. Low side pressure dropping below 25 to 30 psi or high side pressure rising above 250 to 300 psi are red flags. A stuck-open valve typically leads to high suction pressure and low head pressure, while a stuck-closed valve causes the opposite. These imbalances can damage the compressor. A stuck-closed valve causes low suction pressure and high head pressure. A stuck-open valve leads to high suction pressure and low head pressure. These pressure imbalances can damage the compressor. When diagnosing a potential expansion valve issue, start by checking refrigerant pressures with a manifold gauge set. Look for significant deviations from normal operating pressures. Inspect the evaporator core for frost buildup. Also, examine the valve itself for any visible signs of damage or corrosion. Recent real-world examples demonstrate the widespread impact of faulty expansion valves. The Tesla Model 3 recall from 2023 to 2024 affected over 100,000 vehicles, where valve corrosion in humid climates led to air conditioning failures, frost buildup on evaporator lines, and low-pressure alarms. Diagnosis through Tesla's software identified clogged valves, resulting in free replacements and firmware updates that improved monitoring and saved owners an average of $1,500 in repair costs. Similarly, a 2024 case in a New York high-rise building showed how faulty valves caused air conditioning inefficiency across rooftop units, with frost buildup traced to the expansion valves. Replacing them with digital thermostatic expansion valves reduced energy use by 25%, as documented by the American Society of Heating, Refrigerating, and Air Conditioning Engineers, highlighting how urban heat islands accelerate these failures. To prevent expansion valve issues, ensure your AC system is regularly inspected, especially in regions with extreme temperatures. Use high-quality refrigerants and replace the filter dryer as recommended. Addressing minor problems early can prevent more costly repairs down the line. IoT-enabled AC systems are also offering proactive maintenance by predicting valve failures before symptoms manifest. The future of AC systems involves smarter technologies. Variable orifice valves are emerging as replacements for fixed TXVs, offering better efficiency. By 2030, AI diagnostics could automate repairs, with self-healing valves dynamically adjusting orifice size to maintain optimal performance. These innovations promise increased reliability and reduced energy consumption.